This video we're going to relook at the problem of printing every single element of my linked list. But what we're going to do now is we're going to print out every single element in a reverse order. Meaning, given this linked list from the earlier video, given this linked list over here, and my apologies, it got a little bit messier, but the idea is still there. But I have this linked list with 1, 2, 3, and 4 nodes there. I would like to print them out in a reverse order, meaning the final output should be, if correctly implemented, in the order of 4, 3, 2, and 1. This is what I would like eventually to get printed. And I'm going to do this. I'm going to do the solution via recursion. I'm going to do this via recursion here. And we can again compare the forward printing of my linked list side by side. So this is the code. This is the code for printing the forward order of my linked list. I'm going to write on the next over here a recursive implementation for printing the linked list in a reverse order. So let's start that function. I'm going to say def print instead of calling FLL, let's just call RLL. And again, this takes in a head. Okay, this takes in a head because that needs to get printed. That's the first node. Head is pointing to the first node of my linked list. And let's start with a recursive case here. The recursive case here is, remember in an earlier solution, this piece over here was my base case, and this piece over here was my recursive case. Okay, so what is my base case going to be? My base case is going to be the same thing, but I'm going to say if the head is none. What does it mean that head is none? It means that I have an empty linked list. If I have an empty linked list, there's nothing to print, and because there's nothing to print, I'm just going to do return. Okay, head is just pointing at none. If head isn't pointing at none, it's pointing at something. It happens to point at some kind of linked list which has at least one element, at least one node there. What does it mean? What does it mean to print it in a reverse order? What it means is that before I can print one, before I can print this node out, before I can print this element out there, before I can print that one out, I must ensure that every single other element of that node have been printed out in a reverse order. I must ensure everything else has been printed out in a reverse order. Okay, so I must make sure that whatever is the remaining problem, whatever is the remaining subproblem, meaning all of this is the remaining subproblem. Again, my apologies, it's getting really messy, but this piece in pink here is the remaining subproblem. How do I print out the remaining subproblem in a reverse order, starting from 2? Meaning, how do I print this out in 4, 3, and 2 there? Let's just call a recursive function, print RLL. So if I say print RLL starting from head.next, okay? Head.next is basically pointing at this node right there. Just print out every single element of my remainder of my linked list starting from head.next in a reverse order. When that is done, when you've printed that out in reverse order, meaning you've printed this out in 4, 3, and 2, meaning when you've printed the reverse order out of the remaining linked list 4, 3, 2, what is remaining then? What is remaining then is just to print this one out. That's the only piece that's remaining. How do I print that one out? To print that one out, what is it? What kind of a reference? What kind of a reference do I have that still points at 1 when everything has been printed out? Meaning when everything has been printed out, when this is done, right? You're going to have head. You're going to have head that's still pointing at the first node there. Meaning now I'm just going to do print. I'm just going to print on the console whatever head dot element is. Okay, and this is it. This is the solution. Let's just step through this code here. Okay, what is head here? Head at the very start is pointing at this node right there. Okay, is head none? No, head isn't none. So this condition is false. Because this is false, I'm going to print RLL of head.next. What is head.next here? Head.next is pointing at this entire node there. Okay, so let me do this. Let me draw my stack trace to you, just so that we are consistent with this debugging of the code here. First thing, when I call print RLL, the very first time when I call print RLL, okay, that's my stack trace, meaning this is the first item on my stack trace. And if you're not familiar with what a stack trace is, I highly recommend that you watch my video related to the first midterm exam using PyCharm. The entire code was done in PyCharm. I had shown you in debugging how to get the stack trace. So I highly recommend watching that video just to get the idea, the intuition what I'm trying to do in this video here. So the very first time PrintRLL gets called, I'm just going to make a picture here that just gives me a picture that head at that point is pointing at this node that contains the element 1. Okay, just to help me with my debugging. Okay, so head is not none because head is pointing at this node which contains the element 1. I'm calling PrintRLL. When I call PrintRLL again, I'm going to create the function called recursively, and because the previous function hasn't returned yet, it hasn't returned that, you're going to have a new stack frame. In that new stack frame, what am I passing into that function? I'm passing in head.next. What is head.next? Head.next is pointing at this node right there, which contains the element 2. So when PrintRLL gets called, you have a new local variable getting created in the stack frame. The new local variable gets created, head. What is head pointing at that point? Head is pointing at the element that contains the head is pointing at that node that contains the element 2. Is head none? Head is not none because head is pointing at this node with the element 2. Then I'm going to say PrintRLL. I'm calling this function again. So I'm going to say PrintRLL. What am I passing in there? I'm passing in head.next. But what is the head I'm referring to at this point? The head I'm referring to at this point is the head that is local to this function that I just created, which gives us the head that is pointing at the node that contains the element 2. If this is what head is pointing at right now, okay, in that stack frame, head.next is going to point at this node right there. This is what head.next is pointing at. So in this stack frame, head is now pointing at the node with the element 3. Okay, excellent. Now the function gets called again. What is head at this point is pointing at the node with the element 3. Is head none? Head is not none. That condition is false. Because the condition is false, I'm going to call PrintRLL again. But keep this in mind, I haven't yet printed out anything on my console. If you're keeping a track of what is getting printed on the console, let's do this. Let's have a console right here. This is the console of my monitor, okay? And that's my cursor blinking over there to print out every single thing. I haven't yet printed out anything yet, okay? At this point, nothing has been printed out. I call PrintRLL again. At this point, I have my head. That is pointing at this node which contains the element 4. Okay, and it's true that head is not none. I'm just going at this point. Head is none is false. I'm going to call PrintRLL again. So when I call PrintRLL again, what is head.next going to point at? If head is pointing at this node which contains the element 4, head.next is going to point at none. So at this point, head is pointing at none. If head is none, if this becomes true, if this condition, meaning this Boolean expression is true now, what are you going to do? You're just returning. That's all you're doing, you're just returning. But return from where? If this is the function that is currently executing, where are you going to return back to? You're going to return back to right at the previous stack frame. Okay, so if you return back to the previous stack frame, on the previous stack frame, on this stack frame, when you return back to, what is the next instruction to get executed? The next instruction to execute on that stack frame is print head.element. What is head on that stack frame? On that stack frame, head is basically pointing at the node which contains the element 4. What gets printed on the console now? You're saying print head.element. Head.element prints out 4. Okay, so the first thing you see on the console now, this is my console. You see 4 printed out on my console. Excellent. What is the next instruction of the head.element? The function just returns because there's nothing else remaining in your method. It just returns. And because the function returns, so this has been already cleared off. Now this function gets returned. If this gets returned, where does it go back to? It goes back to the previous stack frame. It goes back to the previous stack frame. On the previous stack frame, what is the next instruction to print? The next instruction is print head.element. What is head? Head is this thing right here that is pointing at the node that contains the element 3. What are you going to do at this point? You're going to say head.element print. You're going to print 3. This function then returns and comes back to the previous stack frame. On the previous stack frame, head is pointing at the node that contains the element 2, and you're going to say print head.element, meaning you're going to print back 2. Okay, terrific. So now the function returns. The function returns, meaning this thing has been taken off from the stack. Remember our discussion in week 1. Every function gets allocated on the stack frame when the function gets called. Whenever you're calling the recursive function, your stack frame increased. Your stack increased, meaning you got new stack frames entered on the stack. When the function returns, you start taking items off the stack. You start taking items off the stack there. And finally, this thing comes back to the very first print RLL, at which point head is pointing at the node which contains the element 1, and 1 gets printed. Okay, so this is the implementation to print out every single element of my linked list in a reverse order.